Hello, class. The purpose of this video is to go over the review points from Lab 4, which is regarding submaximal cardiovascular fitness testing. So I have here on the screen Lab 4, and the review points are listed here. So what my plan is just to go to the PowerPoints and go find the appropriate slides relevant to the bullet point listed and sort of talk about that. Okay, so the first review point is to understand when it is appropriate to select a submax test instead of a max test. So let me switch over to the PowerPoint and let's just scroll down, and there it is, slide number 2. So there is a list here, right? I would say in general, we want to consider what the goal of the test is, who the population is, right? The population will largely dictate what we're going to do. Also, what equipment do we have available? Like in our lab, we have access to a metabolic cart, so we can do a max test. In most other settings, gyms, etc., you're only going to have the ability to do submax tests because there is no metabolic cart there. Okay, so those all of the reasons are listed here, and I think that I've said enough there to cover that. So let's jump back over to where's that document? There it is. Point number 2, discuss issues with accuracy, repeatability, as well as why one protocol may be preferred over another. Now, me reading that, I'm not sure if we have a slide which would really dictate that. Although this would be a good place to start, right? We want to make sure that we do administer proper pre-test instructions, because submax tests are mostly dependent upon heart rate. We want to be aware of influences on heart rate outside of the exercise protocol that we are doing, right? So here, for example, medications your client may be on. The temperature, is that going to affect heart rate? If it's really hot in the room you're using or you're outside, etc. Did the person exercise prior to the test? That could have an effect on heart rate, obviously. So I would say in general, the biggest thing that we want to do is be aware of things that could affect heart rate, and then try to, through our pre-test instructions, control for that the best that we can. Because if not, the accuracy could be affected. As far as repeatability, sorry, that was a hard word for me to say. I would say the most important thing there is to know how to do the test, practice it, and make sure that you are consistent with the application of the protocols. Lastly, when one protocol may be preferred over another, what mode is the most familiar to the person? If somebody is a cyclist, then a cycling test is appropriate. For most other people, the treadmill walking test is going to be the most appropriate because everyone walks. One exception could be if somebody has an injury that is aggravated with weight-bearing activity, then you might want to go with the cycle over the treadmill. Or if there are concerns about balance or stability and you would prefer to have them seated. Also, maybe if somebody is obese or overweight, where the non-weight bearing option could be better given that situation, that would be the reasons what I would say you would want to consider as far as choosing one mode over the other. Also, then what equipment do you have available? That's kind of always has to be a consideration there. All right, strengths and weaknesses of estimating VO2 max from a submax protocol. Strengths, this kind of goes back to the appropriateness, right? The strengths are, you're not going to be doing maximal exercise, and that could be more appropriate for most people. Weaknesses could be, it is an estimate, there is an error that is fairly large, plus or minus 5 to 10 ml per kg per minute. That is the error that is associated with submax testing, so that would be a major weakness. The major strength would be that, again, we are not taking somebody to their maximal levels of exertion, so that could be more appropriate for many populations. Also, it is typically less expensive. The equipment required is much less specialized and cheaper for submax testing. So those are some other options. And then in addition to that, there's many tests. Field tests. Compared to max testing protocols, there are many submax protocols. So surely you could find something that is appropriate for your given population. Okay. Is there anything else I want to say about that? Let me just kind of buzz through the slides. Now, it has on these slides going through the different modes, the cycle ergometer, treadmill here, but it does tell you about field testing, exact advantages and disadvantages with the different modes. So it could be good to review that as well. Fourth bullet point is not really necessarily covered on the PowerPoint, but it is talking about measuring and exercising blood pressure. So we have already had a quiz over resting blood pressure. The success rate with that varied. I would say you want to make sure that you're confident in your ability. We didn't spend a whole lot of time in lab like directly teaching that because I sort of assume you come in with that skill. So again, if you don't have that skill, you need to practice it either with a graduate assistant or with me or even with your classmates. Okay. Same is going to apply for this. I would go ahead and assume on this next quiz, you're going to have to take an exercising blood pressure. So what is that going to look like? Myself or the second year GAs, we're going to be seated on the cycle, just like you did in the lab when you took the exercising blood pressure, pedaling slowly. We will need to have the arm supported at heart level. So in many cases, you could rest it on the bike, but if it is lower than heart level, you would want to support it with your own arm, right? So make sure you clamp the subject's arm between your arm and your torso. That will support it at heart level, okay? The other challenge with exercising blood pressure is the additional noise in the movement, right? It is useful to watch the needle jumping and coordinate that with the sound. However, the movement of the cycle could also cause a little movement with the needle on the sphygmomanometer as well. And you're going to be hearing additional noises. Okay, so again, what noise are you looking for? It should be rhythmic in nature. However, the cycle noise is going to be rhythmic in nature as well. So it is going to be more challenging, I would say, to measure the blood pressure when exercising for that reason. Another thing to consider, now if somebody is exercising, their systolic blood pressure will be higher, right? So typically at rest, we recommend you pump the blood pressure cuff up to 150 to 160, which would be roughly 20 to 30 mm per Hg over the resting. You need to consider that when you're exercising. If somebody is exercising, their systolic pressure may be 150 millimeters of mercury. So you want to go up a little higher, maybe to 180 or even 200. So you're going to have to pump the cuff up tighter. It's going to make it more uncomfortable for the subject, so make sure that you do open that cuff up pretty quickly and let the pressure start falling. Okay, so let's recap that. Practice it. Pump the cuff up higher than you would at rest. Make sure the arm is supported at heart level, and try to differentiate the sound of the pulse pressure, the heartbeat, compared to the sound of the cycle odometer, okay? If you're watching this video, I'm giving you a heads up. I'm going to ask you to take an exercising blood pressure on the quiz for Submax exercise testing. Okay, so with that, let's look at the last bullet point. Now, one thing that I know I might ask you, which is not listed here, are the sources of error for Submax testing. So let me jump back. Oh, look at that. The slide was already up. I did mention earlier the error associated with Submax testing. The error comes from these 5 bullet points that we see listed here. I'm going to ask you possibly to name one of these and then explain it. So let me see. I've gone 8 minutes so far. We could go through these quickly. So we assume heart rate and work rate have a linear relationship. That is not totally true. Now, the relationship is the most linear between this heart rate range here, 110 to 150. So any heart rate outside of that range, the relationship is not completely linear. So a good test would try to get the subject's heart rate in between that heart rate range of 110 to 150, right? So if I'm going to minimize my error, I would select a test where I make sure the heart rate gets into this range for the test, okay? Number 2, we assume a steady state is achieved at each work rate. Now that may be true, but we only actually measure it in one protocol. That is the YMCA Submax protocol. That is why we like to do that one in the lab, because that is the only one where you only advance to the next stage if there is a steady state achieved. If not, you do an extra minute in the stage. Point number 3, we assume that the age predicted max heart rate calculation is accurate. That is not necessarily true either. There is a plus or minus error of 11 beats per minute, as you see listed right here. The error tends to vary based upon somebody's age. For younger people, that tends to underestimate heart rate, max heart rate. For older people, it tends to overestimate it. For middle-aged people, which I would put myself in that category, I'm like 47, 48. I hope this is an evergreen video, so I'm not going to give you my exact age, but I'm in my late 40s. The formula tends to be very accurate. Okay, so the age of the person can kind of influence the accuracy. Okay, point number 4, we assume mechanical efficiency is the same for all people. That is false, right? If you look at 2 people running, you have a novice and a well-trained person. The well-trained person is much more efficient with the movement than the novice. Okay, so how do we control that? I mentioned this one earlier. Make sure you choose the mode that is the most appropriate for the subject. What are they the most familiar with? That is going to increase their efficiency. We can also tend to kind of set a speed or a cycling rate that is the most efficient as well. So that's why we use 50 RPMs during a submax test, for example. Okay. The last point, we assume that the subject is not on heart rate altering substances. That could be medication, caffeine, large amounts of stress. Again, the environment being very hot or humid, that can influence the heart rate as well. You don't typically want to have a subject not take their medication. You could, though, recommend that they not drink coffee beforehand, or you make sure your room is thermoneutral. You can control for that the best that you can. Typically, you're not going to have someone not take medication, but you would want to be aware of it. Beta blockers and blood pressure meds tend to reduce heart rate. Allergy medications and asthma medications, they tend to elevate it because they mimic the effects of the sympathetic nervous system. So you would want to be aware if somebody was on one of those 2 medications if you're doing a test which is based upon heart rate response to exercise, right? The accuracy is going to be reduced if somebody is on a heart rate altering medication. All right, back to the lab. Last bullet point was just how ability to conduct the various testing. So, some basic familiarity with the protocols that we did in this lab. So if I kind of scroll down here, let's look at them. The jogging protocol was very, very simple and very quick. So we just have a running speed. We're going to monitor heart rate at the end of every minute. The termination point in this particular test is 180. Now, I did not mention that. For all submax testing, there is a termination point of 85% of age predicted max heart rate or heart rate reserve. Okay, so if I asked you that question on the quiz, what is the termination point for submax testing? It is 85% of the age predicted max heart rate or heart rate reserve. Okay. Now, in this particular protocol, which that is listed right here, the calculation of that, there is another heart rate that is used as well. Okay. And then, as you saw, we took the heart rate from minute 3, popped it into the equation to get our VO2 max prediction. The YMCA Submax cycling test, the protocol is detailed below. So just kind of a basic understanding of how to perform this protocol, right? 50 RPMs the whole time. First stage, you're at half a kilogram. Take the heart rate at 2 minutes and 30 seconds, and that determines which of these stages you go into for the remainder of the test. Stages 2 through 4, take 2 heart rates, 2 RPs, last 30 seconds of each minute, and then if you are in a steady state, you advance to the next stage. Keeping in mind the 85% termination heart rate cutoff. Lastly then, I feel like I'm going to sneeze. We had the A-strand cycling protocol, which is described here. So again, just some basic familiarity with this and roughly could explain it to me for the quiz, okay? So that's going to do it. We've covered the review points. I have 1 minute left in my timer here, so let me just scroll through the slides. Did we miss anything important? We covered this. We covered this. Pre-test instructions, we covered that as well. Basically covered that. And then these last slides are talking about the different protocols, test termination criteria, not only the cutoff for the heart rate, but some signs or symptoms as well. Interpretation. Okay. All right, well, that's going to end this review video for Lab 4 submaximal exercise testing. I hope you found it informative. Good luck on the quiz.